Okay, guys, I guess everyone is here. So let's get started without any further ado. Now, before we get started, a quick introduction on my end. My name is Mohammed Shoaib. I will be your cybersecurity trainer for the entire duration of this course. And this is our second class in the Certified Ethical Hacking version 13 module. We took a simple demo yesterday. I've explained what the course is about, what topics we'll be covering throughout the course, what is the exact curriculum, what procedures will we be covering, okay, and what tools we'll be working on as hands-on. I've explained everything in detail. So if you have not joined that session yesterday, nothing to worry. All of these sessions are being recorded and they will be uploaded on YouTube. So if you want to access the session from yesterday, you can just open up YouTube, search for cybersecurity DURGASOFT, and filter it out by the recently uploaded one, and you'll find the recording there. Okay, from the session yesterday. Okay, so today, again, this will be the first actual class of the course where we talk about networking fundamentals. What is networking? What are networks? What are hosts? What are IP addresses? We're going to cover all that in the session today. Okay. Before we do so, any questions or doubts regarding cybersecurity also? How many of you have joined the session for the first time today? Is anyone new to the session today? Lokesh, Srinivas, Pankaj, Soumya Ranjan. Were you guys there yesterday? Or is this your first class? Joined today for the first time, Pankaj. Okay, no worries, Pankaj. Again, don't worry, you didn't miss out much. As mentioned in yesterday's class, I've only taken up a demo regarding the introduction on what the course is about, what Certified Ethical Hacking version 13 course covers. Okay, so you can access that recording from YouTube as mentioned already. Okay, so let's get started without any further ado. Now, when we talk about networking fundamentals here, guys, there are three important definitions to know. What is networking? What are networks? And what are hosts? So when you talk about networking, this is the practice of connecting information devices with each other. Now, in an organization, you have multiple sort of endpoints. You have multiple types of devices. You have routers. You have your again desktop. You have your laptops. You have your again switches. You have your firewalls. You have your IP cameras. You have your printers. Okay, there are multiple types of endpoints or devices in an organization. The practice of connecting all of these information devices with each other so that they can communicate with each other and start sharing resources or information is called networking. Okay, you can either set up a wired network or a wireless network. Okay, now what I mean by a network is the collection of these devices. So the combined collection of these interconnected devices which can communicate with each other is called as a network. So it's a group of interconnected devices, and each device in that network is called as a host. So a host refers to any device connected to that network that can transmit or receive data. As mentioned already, your computers, printers, routers, mobile phones, IP cameras, your again smart speakers, whatnot. Okay, every single device which here is capable of communicating, sending, and receiving data from other devices is called as a host. Now, just like how we humans have our respective names to address or identify each other, these devices also have names. Those names are called as IP addresses, Internet Protocol addresses. These were built by the US military. They were, again, I would say, invented in the year 1950s or so. And there were multiple experimental versions of it. There was IP version 1, IP version 2, IP version 3. They were experimental. They didn't get released to the public. What successfully worked out and what was released to the world was IPv4, Internet Protocol version 4. And even in today's date, we are still using IPv4 addresses to identify each device in a network. Okay, and this IPv4 address has a few important properties to it. Before we get into the properties, a quick definition of what IP address is. Each host on the network has a unique identifier, something which gives identity to that device. That unique identifier is known as an IP address. And these IP addresses are also used or also allow communication to occur between the hosts. So when one device wants to communicate with the other device, when they want to send data to each other, they have to communicate with each other using these IP addresses itself. They identify each other with these IPs and they send the packets using these same IP addresses. Okay. Now, important properties of your IPv4 address. Firstly, it's a 32-bit address. What I mean by a 32-bit address is that it contains 32 zeros and ones consecutively. A bit is the smallest data value a computer can hold, and it can either contain the value 0 in it or the value 1 in it. Okay, and your IPv4 address is a 32-bit address. It contains 32 zeros and ones consecutively. Okay, and this entire 32-bit address again is divided in 4 equal parts. That's the next point. Okay, and each of these parts is called as an octet because it contains 8 bits in it. Okay, so 8 bits plus 8 bits plus 8 plus 8, that's a total of 32-bit address. Okay, so this entire 32-bit address is divided in 4 equal parts of 8-bit each. Each 8-bit portion is called as an octet, and each octet is separated by a dot symbol. Okay, and this is what your IPv4 address typically looks like. So as you can see, there are 8 bits here, 8 zeros and ones, then a dot, then another 8 zeros or ones, then a dot, then another 8 zeros or ones, then a dot, and then another 8 zeros or ones. Okay. That will be a representation of the entire 32-bit IPv4 address. Now, what you see over here is called as the binary language. The language of zeros and ones is called as binary, and this is what computers inherently understand. Okay, so by default, this is the language that they communicate mostly in. Okay, but we humans don't understand binary so well. What we regularly use are decimal numbers, numbers from 0 to 9. So now I'm going to show you how do you convert any binary number, any computer readable number, into a human readable number or a decimal number. Okay, so this number 11000000 is actually equal to 192. This number 10101000 is actually equal to 168. This number with all zeros is simply equal to 0. And this number 00001010 is actually equal to 10. So now I'm going to show you how do you convert any binary number to a human readable decimal number. Okay, so we'll talk about that conversion now. And in a while, I'm also going to explain why this conversion is important or relevant for us. Okay, so let's take the example of this number here, 10101010. So here we have an octet with 8 bits in it. And now we'll talk about how to convert this binary octet into a human readable decimal number. Okay, so rule number 1, whenever you want to convert a binary number to a decimal number, you write down the values of 2 power 0 all the way up to 2 power 7 from right to left under each binary number. So under the rightmost binary number here, 0, you have 2 power 0, then you have 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and then 2 power 7. So from right to left under each binary bit, you write down the values from 2 power 0 all the way up to 2 power 7 in ascending order. Okay. Now, if you have a question why specifically 2 power everything, this is a binary number. There are only 2 possibilities. So 2 power everything. Okay. Once these values are written down, then you multiply the lower value with the top bit and keep on adding it till the end to get the final decimal answer. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. Okay. So you're multiplying the lower value with the top bit and you're just adding it to the next one. Okay. So to perform these calculations, let me write down the values here from 2 power 0 to 2 power 7. Anything to the power 0 is always equal to 1. It's a mathematical rule. So 2 power 0 is 1 itself. 2 power 1 is 2. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 power 4 is 2 into 2 into 2 into 2, 4 times, that's 16. 2 power 5 is 32, 2 power 6 is 64, and 2 power 7 is 128, similarly. Okay. Now that we have these values here, we can substitute them and get the final decimal answer. So 2 power 0 into 0. 2 power 0 is 1, so 1 into 0 is simply 0. Plus 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2. 2 power 2 into 0, 0 again. 2 power 3 into 1, that's 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. And 2 power 7 into 1, 128. Now that you have all these values written, you just add them up. 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer understands it as 10101010. Something like high frequency, low frequency, high, low, high, low, high, low. When that exact sequence of frequencies flows through a computer, it understands it as the number 170 in human readable language. Okay. Is that clear, everyone? Any questions or doubts up to this point? Lokesh, Aditya, Nikhil, Srinivas, Pankaj, Soumya Ranjan, Subramanyam, Suman, Nikhil. Okay.
And no questions.
Perfect. Now, if this is clear, I have two other numbers, and if you have a pen and a paper beside you, I want you to calculate and give me the final answer for these two binary numbers. 0 1 0 1 0 1 0 1 and all ones. Okay. Take your time, no rush. I want you to convert these two examples, example 1 and example 2, from their binary counterparts to the decimal values. Okay. So again, please do not cheat. Please do not use ChatGPT and stuff. Just give me the calculated answer for these
85?
two. First one is 85. Okay, let's wait for the others' answers as well. And we'll verify this shortly. First one is 0 1 0 1 0 1 0 1, and the next one is all ones.
Second one is 255.
Okay, I've got one answer as 85 for the first one and 255 for the second one. Let's wait for the others as well. A few more answers and we'll confirm these. Okay, I've got one more answer as 85 for the first one. Perfect. All right answers, guys. The first one is 85 and the second one is 255. Okay. So again, oh, 1 second. Annotations. Right. So, so just a second. Lost my screen share. Yeah. I hope my screen is visible now, guys. I hope everything is fine. Yeah, perfect. So again, as mentioned, now, right. So again, if we talk about the first number, 0 1 0 1 0 1 0 1, there's first number over here on the rightmost, you have 2 power 0 into 1, that's 1. Plus 2 power 1 into 0, that's 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, 0. 2 power 4 into 1, that's 16. 2 power 5 into 0, 0. 2 power 6 into 1, 64. And 2 power 7 into 0, 0. 64 plus 16, that's 80. 80 plus 4, 84. 84 plus 1, 85. Okay, that's the first number. And when you have the second number with all ones, you add everything up. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And when you add everything, you get the number 255. Now, The reason I'm explaining you all this is so that you can understand the range of IP addresses. So if I have to get the first IP, all I have to do now is simply put zeros everywhere because that's the minimum value obtainable. Okay. To get the least value or the most minimum value obtainable in the IPs, I would just put zeros everywhere. So if I put all zeros on the first octet, all zeros on the second octet, all zeros on the third and fourth octets as well, the first IP we have is 0.0.0.0. That's the first IP. And if I have to get the last IP, how do I get that? Just put all ones everywhere. So when I put all ones, that's the maximum number I can obtain for an octet. So the last IP would be 255.255.255.255. You yourself just calculated and gave me the answer for all ones, which is 255. Right? So in your IPv4 address range, guys, you would never have IPs beyond the number 255. Reason being, when you put all ones in the octet, which is consisting of 8 bits, the maximum value it can obtain in the decimal value is 255, not more than that. Okay. So no matter what IPs you have, they would always exist between the values 0 and 255 for each of the 4 octets. Okay. And if you have to count how many IPs are there in total, each bit over here has two possibilities, 0 or 1. Okay. And there's a total of 32 bits. Okay. With a simple permutations formula to get the total number of IPs, you would just simply type 2 to the power 32. So 2 raised to the power 32, which is equal to 4.3 billion IP addresses. If you ask me how did you get this number 2 to the power 32, as mentioned, each bit has two possibilities and they are 32 bits. So 2 into 2 into 2 into 2 into 2, 32 times 2 raised to the power of 32. Okay. Again, that is approximately close to 4.3 billion IP addresses. So back then when these were invented in the 1950s or so, 4.3 billion IPs was a very large number. You didn't have mobile phones then. Not many people owned computers then. Okay, only organizations had them at that time. Okay, and very rare organizations as well. But fast forward to 2025, the population itself is close to 9 billion people. Okay, or could be more than that as well. Okay, and each person could have multiple devices again. So if you had assigned each single IP to each singular system in today's era, these IPs would never have sufficed. Okay, so these 4.3 billion IPs to be sufficient have been divided in various categories. There's something called as classes, class A, B, C, D, and E. And again, each class has two subcategorizations, public and private IPs. So to give you a better idea, this is a diagram representing how the IPs are divided. So if this white rectangle, the entire white rectangle, if that represents the 4.3 billion IPs, that white rectangle is divided in five smaller rectangles, class A, class B, class C, class D, and class E. And again, in each of those rectangles, there are two subdivisions. Class A has public and private IPs. Class B also has public and private. Class C also has public and private. Class D and Class E are exceptions. There are no private IPs in Class D and Class E. All of them are public IPs itself. Okay. So this is how the IPs are categorized, I would say. Okay. Now, before we talk about these categorizations, last thing for today, let's talk about the sequence of IPs. Okay. We know what the first IP is. We know what the last IP is. What about the IPs in between? How are the IPs progressing one after the other? Let's talk about that today. Okay. So to understand the sequence of IPs, there are two simple rules again. Rule number one, always start incrementing from the rightmost octet. Okay, so that's rule number one. Okay, so we have the first IP as 0000. The next IP would be simply 0001. So the rightmost octet is incrementing by one. Okay, incrementing in the sense increasing by the value of 1. Okay, so the next IP would be 0002. Next IP 0003. Next IP 0004. This goes on all the way up to 000255. Now after 000255, you can never have a value like 000256. That's not possible. So once you reach the maximum value here, then comes rule number two. So that rightmost octet resets back to 0, and then the left octet increases by 1. So once the rightmost octet has reached the maximum value, move to the left octet. So the left octet now increments by 1. So after 000255, you have 0010. Now after 0010, don't directly jump to 0020. That would be wrong. Remember rule number one, always increment the rightmost octet. So after 10, you have 11, 12, 13, 14, 15, 16, which goes all the way to 155. Then you have 20, 21, 22, 23, 24, which goes up to 2255. 30, 31, 32, 33, which goes up to 3255. I'm skipping a lot of IPs in between, guys, but I hope you get the gist of it. Okay. So the sequence keeps on repeating again and again and again. And somewhere down the line, you would have 2550, 2551, 2552, 2553, 255, 255. Both these octets are full now. What happens next? All of these cycle back to zeros, and the left octet increases by 1. So after 0, 0, 2, 5, 5, 2, 5, 5, you have 0, 1, 0, 0. Okay. The 255s cycle back to zeros, and this next octet, the left octet after that, increases by 1. So if you notice, you have 0, 0 again, the first sequence of pattern. Okay. So whatever repeated all the way from 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5, same thing repeats from 1, 0, 0 to 1, 2, 5, 5, 2, 5, 5. Okay. So 0, 0, 0, 1, 0, 2, 0, 3 goes up to 0, 2, 5, 5. 1, 0, 1, 1, 1, 2, 1, 3 goes up to 1, 2, 5, 5. 2, 0, 2, 1, 2, 2, 2, 3 goes up to 2, 2, 5, 5. Like that, the sequence goes on and on and on. Somewhere down the line, you would have 2550, 2551, 2552, 2553. This goes up to 255, 255. Once both these octets are full, then this 1 changes to 2. Okay, so same pattern, whatever repeated from 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5, repeats again from 1, 0, 0 to 1, 2, 5, 5, 2, 5, 5. Then 2, 0, 0 to 2, 2, 5, 5, 2, 5, 5. 3, 0, 0 to 3, 2, 5, 5, 2, 5, 5. 4, 0, 0 to 4, 2, 5, 5, 2, 5, 5. Like that, somewhere down the line, you would have 2, 5, 5, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5. All the three octaves on the right are full. So the last 0 now increments by 1. So after 0, 2, 5, 5, 2, 5, 5, 2, 5, 5, you have 1, 0, 0, 0. Okay. Just like this first IP again. Okay. And whatever cycle repeated all the way from the first IP here to here, 0, 2, 5, 5, 2, 5, 5, 2, 5, 5. Same pattern repeats from 1, 0, 0, 0 to 1, 2, 5, 5, 2, 5, 5, 2, 5, 5. Again from 2, 0, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5. 3, 0, 0, 0 to 3, 2, 5, 5, 2, 5, 5, 2, 5, 5. 4, 0, 0, 0 to 4, 2, 5, 5, 2, 5, 5, 2, 5, 5. And finally, down the line somewhere, you would have 2, 5, 5, 0, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5, 2, 5, 5. That's the entire pattern. And if you count each and every single IP, you would have a total of 4.3 billion IP addresses. Okay. The sequencing is important later on. I'll explain where. Okay. But for now, I hope you have understood how the sequence is flowing. Okay. If you don't understand it, don't worry, just refer this one more time. It might seem a bit tough for the first time to get it, but just refer the recording again one more time once it's uploaded on YouTube. Okay. For now, any questions or doubts up to this point?
Sure. Actually, I have one question. So when we open a CMD and when we type ipconfig means it will show IPv4 and IPv6 addresses, right? Actually, what is the difference between IPv4 and IPv6 addresses?
When you talk about IPv6 addresses, those are much more updated version of IP addresses, Subramaniam, where they are hexadecimal addresses. Your IPv4 is only binary addresses, which can be converted to decimal numbers. Okay. So you have 32 bits in it, okay, which is a very small address. IPv6, on the other hand, is 4 times the length of it. It's 128 bits, okay, and that is
So,
completely different. Where, oh yeah, Subramaniam, you see.
so IPv4 and IPv6 means internally represent the same, I mean to say same IP address.
Not really. Again, there's again just like how we have public and private IPs in IPv4 range. Similarly, there's something called as multicast and global unicast addresses. Okay, so it represents the same thing. It is just a private IP for your device, a unique IP address assigned to your system for communication, but slightly different compared to the logic of public and private IPs in IPv4. Okay, we'll cover that as well in the upcoming sessions. Don't worry.
Sure,
But for now,
sure,
let's
sure.
stick to IPv4 because that is already too confusing enough. Okay.
Okay, okay, sure.
Just to give you a gist of it, as mentioned, it's slightly longer. I would say 4 times the size. It's 128 bits. And it has hexadecimal characters. It contains alphabets.
Just one more thing. Actually, the DNS addresses also will be the exact means this binary decimal only, because usually DNS addresses will be 255 point something something something. In that way, it will be there, right?
Yeah, you have IPv4 addresses for DNS also. So it doesn't have to be just 255 something. For example, Google DNS server IP is just 8.8.8.8 or 8.8.4.4, right? Those are the Google DNS server IPs. Okay. So DNS servers will also be having both IPv4 and IPv6 addresses. Depends from organization to organization if they have migrated to IPv6 or not. That's all.
Okay, means actually means this act and means the internet service providers have observed DNS addresses started with 255 generally.
I don't think so, because even I'm using ACT as well. So if I type ipconfig space slash all, you will notice my DNS server here is starting with something like 106, 51, 40, 181. You don't usually
Okay.
have 255 something because that's
Sorry,
past.
that is subnet mask. Sorry.
Yeah, that's subnet mask. Subnet mask is different. That's not an IP address. This is to identify which IP belongs to which class. Okay, so that's called the subnet mask. So don't worry, I'll
Okay.
discuss this also. So there's a topic called subnet mask. If I just go a few slides in the front, so we'll cover all this in the next class actually. What is IPv4 address? What are the ranges of each class? We'll be talking about all this. What is class A? What is class B? What is class C? And then we talk about subnet mask. What is subnet mask? What is class A subnet mask? Class B subnet mask? Class C subnet mask? What is the representation of it? Why do we need subnet mask? We'll cover all that as well.
Okay.
So again, a very lengthy topic. I'm going to break it down in smaller portions over the next few days. Okay, but yeah, we'll cover everything that is required to learn about networking. So we'll talk about the categories of IPs. We'll talk about classes. We'll talk about subnet mask. I'll talk about how to assign an IP manually and automatically from a DHCP server. What is a DNS server? Okay. What are the special IPs? Okay. What are IPv6 addresses? What is CIDR? We'll cover all this in the upcoming sessions. Okay. So, but yeah, as mentioned, a very lengthy topic. I'll have to break it down in smaller portions. Okay. So yeah, don't worry. I'll cover all these upcoming concepts, Subramanian.
Okay, sure.
Sure. So yeah, again, last thing for today, as mentioned, guys, we were talking about the sequence of IPs. So that is how the sequence flows. Okay. The sequence is important to understand if, in the upcoming sessions as well. So please refer to this one more time if possible through the recording, which will be uploaded on YouTube. Okay. But yeah, any questions or doubts up to this point? I think we can conclude over here for today. We've talked about what networking is, what networks are, what hosts are. We've talked about properties of IPv4 addresses. Okay. How do you convert a binary number to a decimal number? From that conversion, we got to know what the first IP is, what the last IP is, and then we talked about the sequence of IPs. Tomorrow, we're going to cover the remaining topics. What are classes? What are public and private IPs? What is class A? What is class B? What is class C? What is class D and E? What is subnet mask? Okay, how to assign a private IP? We'll cover all this in the next session, guys. Okay. So yeah, that's that. Nothing further for the session today. As these are demos, I'm taking slightly shorter sessions. There are new students joining every single day. I don't want them to miss out too many topics. Okay. So that's it for today. Any questions or doubts before we exit the class today, guys?
Nothing from my section. Thank you.
Perfect. Others as well?
The class
Any
duration
questions?
will be 45 days, right? What is the duration?
Yeah, 35 to 45 days.
Yeah, maybe actually, I wanted to know. This is like first time I'm joining, so the content-wise, I think you described yesterday, right?
Right, Pankaj. I have explained the entire course
So
content, what topics we'll be covering, what is hacking cycle, what is the exact procedure that we work on in real time in organizations, what tools we'll be working on. So I've discussed the entire course curriculum and the topics we'll be covering as well in the last session. Uh, Again, as
I,
mentioned, I think
mhm.
the
I think
organization
I
might
can
have
check
dropped.
that maybe course content on uh,
Yeah, on YouTube.
YouTube
I think
recorded
you,
session, is it?
the
Yeah.
Durgasoft must have dropped a link as well. Yeah, there's a link in the chat box if you notice. YouTube channel. So that's your DurgaSoft channel there. You can search for videos. And here, just filter by latest. And you should have one of this as cybersecurity. Yeah, over here, 22
Okay.
hours ago. This was the one which we covered yesterday.
Okay, I'll check
I can
this.
drop this exact link in the chat box. I think that's better. Yeah, I've dropped the link for the video yesterday, guys, for the class we took yesterday. That's the YouTube link for the session yesterday. You can make a note of it. Any other questions? Any other queries, guys? Pankaj, questions?
No, I think that's all.
Hello.
Uh, Hello. Tushar,
Yeah, no questions.
Tushar, were you saying something? I can hear you. Yeah.
Hello.
Yeah, Tushar, I can hear you. Hello. Tushar, can you hear me? I can hear you as well. Okay. Uh, Anyways, I think Tushar is unable to hear me. But yeah, that's it for today's class, guys. Nothing further. As mentioned, we'll be connecting back tomorrow at the same time to cover the remaining left out concepts.
Hello.
Okay. Oh yeah, Tushar, I can hear you. Hello. I'm from non-technical biology. Again, completely sufficient, Tushar. As mentioned, what we are covering currently is a prerequisite itself. All the prerequisites are included in the course. We're going to talk about networking fundamentals. We'll talk about Linux commands. We'll talk about the virtualization setup required. And then we'll dive into the advanced concepts. So this course is more than sufficient for you to get a job as an entry-level professional for cybersecurity. Okay. Why DBY2? Again, this is a regular class itself being taken as a demo. Why? So again, as mentioned, we had the course content demo yesterday. Today is the networking classes, networking concepts demo. Okay, it is the actual class itself, a part of the actual live course itself. Okay, but still being taken as the demo. I didn't want to repeat the same demo as yesterday, so I've started the regular class. Okay, but again, after 2-3 days, the link will change. It will only be provided to the registered people, and we'll be continuing from there on with the remaining topics. Okay, I won't be covering these previous topics again. These are the regular classes itself being given as a demo session. Okay, for the first 2-3 sessions. After that, we'll have the actual actual course. Can I get the YouTube link for the registered ones? No, you'll be getting the again a Google Drive link. So once the course is done, I mean, once you have registered, again, all the videos will not be uploaded to YouTube anymore. After that, you'll be getting it directly on your Google Drive. The institute is going to share those recordings to you over the Google Drive. Only the demo classes will be on YouTube. First 2-3 demos. That's it. Right. Any other questions, guys? No, Tushar. Currently, this is only online. There is no offline course. Yeah, definitely. Srinivas shouldn't be a problem. Again, as mentioned, I've had people joining from completely non-technical backgrounds as well. I've had people coming in from marine engineering. I've had people coming from the railway engineering and they've still secured jobs in cybersecurity. So it shouldn't be a problem. It is completely open for all. The only thing is you need to know how to run these tools, which I'm going to show in the upcoming sessions, how to work on these tools efficiently and perform penetration testing with it. Okay. That's the main agenda. So if you're familiar with that, you can again apply for online. Again, you can apply for freelancing jobs as well. There's a lot of them for cybersecurity, or again a permanent job itself. Okay, the regular 9 to 5. Right. Any other questions, guys? Okay. Assuming no questions, we can exit the session here. We'll connect back tomorrow at the same time. Please do join the session tomorrow without fail. Quite an important class. We will discuss further concepts on networking in depth. Okay. Bye bye. Good day. See you tomorrow at the same time. Thank you.